55 reads, which of the following systems of inequalities is represented by the shaded region of the graph below? So, as always, you want to take a look at the choices that you have. All these 5 choices, you'll notice that the equations of the lines given are in what's called slope-intercept form. Y equals mx plus b. Now, we see the graph, and there is this shaded region right here. This is the solution set of this system of inequalities. We don't know which system corresponds to that graph. That's what we have to be able to choose. Now, we see 2 lines, so you should recognize these, the graph as containing 2 lines. We're going to call this one line 1. And let's call that one line 2, actually. So let me just change this. Doesn't matter, but I'd rather call this one line 1. And this one will be line 2. Now, the solution set or shaded region here, this, as you will see, is going to allow us to pick the right system. So first of all, we have to look at each of these lines, line 1, line 2, and we have to figure out the equation in slope-intercept form for each of those lines. We can actually use the choices given here and see which one's a match. We don't have to work it out, but because I'm explaining to you how this works, we never know what type of problem you might face. I'd rather do that. Remember that the slope-intercept form for the equation of a line contains the slope, which is always rise over run. Remember, that's the m value, rise over run. We'll see how to use that in a second. And then the b value, this is called the y-intercept. And it's the place where the line crosses the y-axis. We'll see how to use that in a second. So let's focus on line 1. For line 1, if we want to figure out its equation in slope-intercept form, in this form, we see that there's 2 points that they give us. Point -1, 0 and point 0, 1. With those 2 points, we're going to be able to figure out everything, or at least the equation in slope-intercept form for that line. So first of all, as to the slope for line 1, if slope is rise over run, well, the trick is to put yourself in a known point of the line. In this case, it's convenient to imagine that we're standing right there at -1, 0. Now, to get from this point to the next known point, which is 0, 1, ask yourself, how many units do you rise and how many units do you run to get there? So to get from here to here, from -1, 0 to 0, 1, standing here, you're going to have to go up, rise, 1 unit, because you're standing at level 0, if you will, and you have to get to level 1, so you're going to rise 1 unit. Now, how many units are you going to run forward? Well, once you're temporarily here, you have to run forward 1 unit, because you're at -1 on the x-axis, and you want to get to 0 on the x-axis, because that's the value of the x of that point. So you run forward 1 spot. So you found the slope for that line, 1 over 1, which is equal to 1. Now we're going to be able to plug that value of 1 for its slope here in the slope-intercept form for m. Now what about the b value? Well, the b value is the y-intercept, the place where the line crosses the y-axis. So this right here is the y-axis. Where is this line crossing the y-axis? Right here at 0, 1. So it's crossing the y-intercept at a y value of 1, which means that b for this line 1 is equal to 1. That's the x, y coordinate, 0, 1, crossing at a y value of 1, so that's the b value. Remember, b is the y-intercept. So if we use these 2 values, m1, b1, and plug it into the y equals mx plus b format, we get y equals parentheses 1 for m times x plus parentheses 1 for b. Clean it up. 1 times x is x, and then plus 1, no need for these parentheses here. So this is the equation for line 1. Line 1 has the equation, therefore, y equals x plus 1. And scanning the choices, you see that all choices contain y and then x plus 1. So, makes sense. Remember how I told you that just by looking at the choices, you could quickly determine the equation of one of the lines. If all the choices contain a y some relational symbol x plus 1, clearly one of the lines equation is going to be y equals x plus 1. But again, I need to explain how this works. Okay, so now that we've determined the equation for line 1 right here, and it's y is equal to x plus 1, we should determine the equation for line 2. Again, looking at all choices, well, A and B seem to think that it's y equals x minus 3, and C, D, and E seems to think that it's y equals negative 3 halves times x minus 3. Let's see which one's correct for line 2. Well, again, stand on a known point of the graph for that line. So I'm going to stand on negative 2 comma 0 right here. The next known point given is 0 comma negative 3. Okay, so remember, y equals mx plus b is the equation in slope-intercept form of a line where m is rise over run. That's the m value. And then b is the y-intercept, the place where the line crosses the y-axis. In this case, if I'm standing here and I need to get to this point right here, let's try to figure out the slope. How many units would I rise? Now, rise, would imply that you're going to go up. But in this case, going up is not going to get me closer to this point right here. I actually have to go down. Now, if I'm at the 0 level right here, and I'm going to go down to 1, 2, 3 to the negative third level, so that's 1, 2, 3. Notice that I'm going down. And if I'm going down, that means my rise value is going to be negative. So down 3, negative 3. Then divided by, what's the run value? Well, I'm temporarily here, but I still have to get to this spot right there. So I need to move forward 1, 2 spots. Because I'm moving to the right, it's positive. So it's 2 spots plus 2. If I have to move, say, to the left to get to the point, then it would be a negative value. But that wasn't the case here. So remember, you start at a known point of the line for the lines whose equation you want to figure out, and then you try to get to a next known point. And then using rise over run, you can easily determine that line's slope. If you go up for the rise, it's positive. If you go down, as in the case of this line 2 here, then it's negative. If you go to the left to get to the point, then it would be a negative run. And if you go to the right, then it's a positive run. So it seems that the slope for this line 2 is negative 3 halves. That automatically means that A and B is incorrect. I mean, you can see that because the other line said x minus 3, that it would imply a slope of 1 and 1, which is incorrect. So right away, we know those two are incorrect. We would automatically know that the equation is going to be y equals negative 3 halves x minus 3, because that's the, all the other choices have that as the equation of that second line. But let's figure it out anyways. Let's see where the y-intercept is. Well, notice this point. This is the y-intercept. And this is at 0 comma negative 3, a y value of negative 3. So b is equal to negative 3 for this line 2. Plugging in, we get y equals m. So parentheses, negative 3 halves, close, times x, and then plus, well, let's plug in the b value now, which is negative, open a parentheses, negative 3. Let's clean this up. You get y equals, parentheses, negative 3 halves, close, times x, and then when you add a negative, you're subtracting, so minus 3. And this is the equation. So line 1, y equals x plus 1. Line 2, it is y is equal to parentheses, negative 3 halves times x minus 3. We now know the equations of both lines. But remember, we need to know which system of inequalities corresponds to this region here, to this graph. Well, we've already determined that A and B cannot be right. So we essentially need to see if C, D, or E, which one of those is correct. What would be the next step? And again, this may not necessarily be what you would do on a test, but because I'm explaining the concepts, it's important that we go over all of these things. And so once you know the equations that form the system of inequalities, in this case, these two right here, focus on the region that has been shaded. You'll notice that out of 1, 2, 3, 4 possible regions formed by these lines, just one of the regions has been shaded. That's going to be important. It's going to give us a clue in a minute. Next, you can always say pick a point that is inside that shaded region. Let's pick this one. That's a nice coordinate to pick. That point has an x value of 1 and an output, a y value of 0. So it's the point 1, comma 0. Whichever system of inequalities we pick, it must include or correctly satisfy that point. And we'll see how to do that in a sec. All right, so let's begin with line 2. Line 2, as you already know, has the equation y equals parentheses negative 3/2 times x minus 3. You'll notice that the relationship symbol being used here is the equal symbol. However, all of the choices have a greater than or less than and equal symbol. So what's going on? Well, when you have systems of inequalities, you will typically encounter that. It means that essentially you want to graph all of the points that satisfy that condition. And we just need to know if the relationship symbol for this graph should be greater or equal, or if it should be less than or equal to. So which one do you think is correct? Well, here's a way to work it out. Line 2 is this one right here. Yes, it's a solid line. When the line itself is solid, it means that the equal is going to be part of the inequality. And yes, you can see that all three choices contain the equal. If the line had been dashed like this, then it would exclude points on the line, and so you wouldn't see the equal symbol being used. You would either see something like y is greater than or y is less than, without the greater than or equal to or the less than or equal to. Okay, so that's how you know if you should include the equal as well. In this case, again, because both lines are solid, neither one of them is a dashed line, you know that for both equations you should see the equal option as well. And yep, you see that all choices contain the equal symbol as well. Now, is it greater than or less than given the shaded region? Well, think of it this way. If you're standing on this line right here, we're looking at line 2. If you're standing there, is the shaded region above the line or below the line? If it's above, it corresponds to a greater than symbol. If it's below, then it would be a less than symbol. We'll see why in a sec. In this case, because the shaded region is above line 2, you're going to go with greater than. Now, we've already said that greater or equal to corresponds, so right away we know that for line 2, the system of inequalities should contain this as part of its expression. Y greater than or equal to negative 3/2 times x minus 3. That automatically means that D is incorrect. So we can eliminate that from our options. Now, let's focus on the other line, line 1. Well, you do a similar exercise. Imagine yourself standing on the line and ask yourself, is the shaded region above or below the line? If it's above, then it's greater than. If it's below, it's less than. In this case, the equation is y and then x plus 1. We know that the equal is going to be part of it, but we don't know if it's greater than or less than. But look at both choices. Both choices contain a less than. So that tells you that, yeah, because the shaded region is below the line, less than should be the symbol being used. And yeah, along with the equal symbol, this is the correct equation that we should see on our system of inequalities. So now that we have the two equations that are part of the system of inequalities with a greater than or less than relationship symbol, we now need to know if we're going to go with the or option or with the and option. So whenever you have a single area like this, where two lines are being used that are just like these, what you're going to find is that the and is the way to go. Why? Because think of it this way. Let's say that we use the or symbol. Well, when we look at line 2, the inequality reads y is greater than or equal to negative 3/2 times x minus 3. This is line 2 right here. This is line 2. And then a greater than means any point above the line. Any. So that means that we would need to see this region shaded as well. If the or option was there, we would see all of this being shaded. To boot, when we look at line 1, this is line 1, right? And line 1 has a less than symbol. That means that anything below the line is going to be valid if we just focus on this line exclusively. So we would need to see everything under that line shaded. That means that if the OR option was correct, not the AND option, it would include any point here, here, and here. So that would be the graph that we would be seeing. A shaded region that would only exclude this region right here. But that's not what we're seeing. We're seeing only the region that is both part of this line's solution set and this line's solution set. That means that the conditional AND is the one that works in this case. Why? Because AND means that both conditions must be met for the... Okay, so to recap, we have line 1 over here, and line 1 was y is less than or equal to x plus 1 because the shaded region lies below line 1, and the equal symbol because it's solid. Then for line 2, we know that line 2's equation is y greater than, because the shaded region lies above it, so greater than or equal to because it's solid. And then the equation, which is parentheses negative 3/2 times x, and then minus 3. Finally, we saw that, well, A and B is incorrect. D is incorrect because it doesn't have the right inequality symbol here for line 2. And so we've already determined that C cannot be right because of the conditional OR, that it must be E. Finally, I want to show you what happens when you remember that point we picked, the 1 comma 0 that is part of the shaded region. Oops, sorry about that. Let me okay, so this is the coordinate 1 comma 0. Let's put this system of inequalities to the test. Let's put E to the test with a point 1 comma 0, which we know is in fact part of the solution for the system. This is saying that when x equals 1, y equals 0, and that both inequalities, the system both are going to be true given this point. So take the first part of this inequality right here, of this system of inequalities. Y should be less than or equal to x plus 1. Well, which x value are we using? An x value of 1. So if x equals 1, let's plug it in. Is y less than or equal to, plug in 1 plus 1 when we use this coordinate? Is y less than or equal to, well, 1 plus 1 is 2. So is y less than or equal to 2? Well, the y value is 0. So is 0 less than or equal to 2? Absolutely. Yes, it is. So this part is true for this point 1 comma 0. What about if we use the same point but now on the other inequality? So that means that we take the y is greater or equal than parentheses negative 3/2 close times x minus 3. Is this going to be true given the point 1 comma 0? Well, again, x equals 1, plug it in, so we get y is greater than or equal to parentheses negative 3/2 times 1 and then minus 3. So y would need to be greater or equal than negative 3/2 times 1 is simply negative 3/2. And then we're going to subtract 3 from that. So let's finish this off. I'm going to erase this part right here so we have some room. And again, we're testing to see if this point does in fact make this statement or this inequality be true. That's what we're trying to determine. Well, how do we subtract negative 3/2 minus 3? How do we do this? Well, we have a fraction and a non-fraction, so we need to convert the 3 into a fraction. So we do that by multiplying. First, you put it in fraction format, dividing by 1. And then you want to have it in the terms of a denominator of 2, so you achieve that by multiplying the denominator times 2, but then you have to multiply the numerator times 2 as well, so that you find the equivalent fraction for 3 over 1. So that leads to y is greater or equal than negative 3/2, and then minus, well, 3 times 2 is 6, and 2 times 1 is 2, 6/2. Now you'll notice that we have a negative here. It's best if we do this. We incorporate the negative sign into the numerator. So y should be greater or equal than negative 3 everything divided by 2, and then minus 6 halves. So how much is negative 3 minus 6? Well, negative 3 minus 6 is, of course, negative 9. So let me do that. So y should be greater or equal to negative 9, because negative 3 minus 6 is negative 9, divided by 2, because the fraction obviously stays the same. We're subtracting fractions. So is this true for this point 1 comma 0? Well, the y value is 0. So is 0 greater or equal to negative 9 halves? Absolutely, it's true. So you see that this point, which we picked because it's kind of an easy point to work with, does in fact satisfy correctly this system of inequalities. And again, the reason why we used and is because only one region is shaded out of the 4 possible regions that we could have ended up with. And given this condition for line 1, we knew that all of this was possible. And then given this condition for line 2, we knew that all of this was possible. So the only place where we see regions intersecting for both lines is this one. So the conditional and has